Okay, so now let's look at the 30, 60, 90 triangle and figure out the 6 trig functions. Actually, we may just focus on the 3 trig functions because you'll be able to just do the reciprocals on your own now. So we'll focus on the sine, cosine, and tangent for the 30 and 60 degree angles. To do this, I need to design the triangle or set up a triangle. Before I can do that, I'm going to start with a triangle that may be familiar with it to you. It's called an equilateral triangle, where all 3 sides are the same. Okay, so I'm going to try to draw one of these. That's not too bad. Might be off a little bit, but it's not too bad. So I got an equilateral triangle. In an equilateral triangle, all 3 sides are the same, which means all 3 angles have to be the same. Well, if all 3 angles are the same and we know they all add up to 180, that means all 3 of them have to be 60 degree angles, right? So I'm going to write 60 in there, 60 in there, 60 in there. Okay, so imagine for a moment cutting this triangle in half vertically, okay, or from one vertex down. I'm going to erase the 60 degree angle there, and I'm going to draw a perpendicular line to the other side, okay? What we're going to do, this is a perpendicular bisector. It also bisects the angle, okay, on top. And so what we end up with are 2 triangles that are similar triangles. They each have a 30 degree angle on top because it's half of the 60, a 60 degree angle on the bottom corner, and then a 90 in the middle. So I'm going to zoom in. I'm going to take one of these triangles off, essentially, and zoom in on it so you can see a little bit bigger view of what that would look like. Okay, so that's a little bit bigger view. So we've got our 30, 60, and 90 degree angles. Now, to make this work nicely, again, I could use any side lengths I want on this thing, but to make it work nicely, I'm going to use a side length of 1 on the base here. What's nice about this triangle is based upon where it came from, the equilateral triangle, if one part is length 1 here on the bottom, that means the whole side length must be double that, right? It's 1 and 1 on each side, which makes 2. And if all 3 sides are the same, then that means the hypotenuse on this triangle is 2. Right? So 2, 2, and 2. They're all 2's. So I've got a 1 on the bottom, a 2 on the hypotenuse. The third side then can be found using the Pythagorean Theorem. So I'm going to call that side B, and we'll plug everything into the Pythagorean Theorem, which says a squared plus b squared equals c squared. A will count as 1, so that's 1 squared plus b squared, we don't know, is equal to 2 squared. Okay. Solving for b then, I get 1 plus b squared equals 4. Subtract a 1 from both sides. I get b squared is equal to 3. And of course, when we apply the square root property, we get b equal to the square root of 3. Okay, again, I want the positive version of that. So square root of 3 is my vertical side here. And so when I come up, now that I know my 3 sides, when I come up with my trig functions, I can just use 1, 2, and the square root of 3 as the sides. So let's look at the 60 degree angle first, then we'll go over to the 30 degree angle. So the sine of 60 degrees is opposite over hypotenuse. So we go to the 60 degree angle, the opposite side is b, which was root 3, over the hypotenuse, which is 2. So that is root 3 over 2. No need to rationalize the denominator because it's already a whole number. The cosine of 60 degrees, well, the cosine is adjacent over hypotenuse, so that's 1 over 2, or 1/2, maybe I'll just write that a little simpler. Okay, so 1/2, that's a nice one. And then the tangent of 60 degrees, well, the tangent of 60 is the opposite over adjacent, so that's √3/1. Okay, or just simply √3. I'm not going to write the 1 on the bottom again, that's unnecessary. So this gives us our 3 trig functions for the 60-degree angle. And you guys could figure out the reciprocals of those, right? So the sine's reciprocals of cosecant, you could flip that and simplify. Cosine with the secant would be 2, and then the tangent, the cotangent would be the reciprocal of √3. Okay, so you can do those reciprocals on your own. Now let's take a look at the 30-degree angle, and we'll find the 3 trig functions for the 30-degree angle as well. So we'll start with the sine. Okay. The sine of 30, of course, is opposite over hypotenuse. So for 30 we go 1/2, which makes sense because it matches the cofunction identity we talked about earlier in this section, because the sine of an angle should be equal to the cosine of its complement. Okay. We also have the cosine of 30 degrees. Cosine of 30 is adjacent over hypotenuse, which is √3/2. Again, that matches the cofunction identity because the cosine of 30 and the sine of its complement should be the same value, right? Both √3/2. And then the tangent of 30 degrees, well, the tangent of 30 should be opposite over adjacent, which is 1/√3. 1/√3, but of course, when you do 1/√3, you have to rationalize that denominator, so I'm going to multiply top and bottom by the square root of 3. And that will give me a tangent of √3/3. Okay. So there's the tangent of 30 degrees is √3/3. Okay, so that gives me the 3 main trig function values for 60-degree angles and for the 30-degree angles. And again, you could come up with the other 3 trig functions using the reciprocals of those.